Algebra 1, Lesson 8.1, Adding and Subtracting Polynomials. Learning target, I can classify, add, and subtract polynomials. Polynomial. Terminology. A polynomial is a combination of variables raised to whole number powers and constants. Recall that whole numbers are the set of numbers that go from 0 to infinity with no fractions. So it's basically the non-negative, non-fractional numbers. Monomial is a polynomial with one term. Degree of a polynomial, the sum of the powers of the variables in a monomial that is the largest in a polynomial. Why polynomials? Polynomials are used in every area of human study that uses math. This includes science, engineering, business, economics, sociology, political science, health, etc. Finding the degree of a monomial, example 1. What is the degree of each monomial? Well, looking at number 1, we see that the exponents are 5 and 8. 5 on the variables, 5 plus 8 equals 13. So for number 1, this is a 13th degree polynomial. For number 2, since 7 really equals 7 times 1, which is 7 times x to the 0, this is a 0 degree polynomial. For number 3, we have 14. X is to the first power, so it's a first degree polynomial. Example 2, adding and subtracting monomials. The first thing to note is we can only add and subtract polynomials or monomials that have the same variables to the same power. So in this example, we want to look at the sum or the difference. If we add, we're summing. So in the first example, we have 4x squared plus 8x squared. Since the variables are x and they're both squared, these are like terms, and I can add the coefficients 4 and 8 to give me 12x squared. In example 2, I also have the same variables to the same powers. X is to the first power, y is to the second. So 7 minus 9 is minus 2 x y squared. The standard form of a polynomial is always written from highest degree to lowest. Example 3, 2 ways to name a polynomial. Looking at the number 6, we know that 6 is really 6 times x to the 0, so that's 0 degree. The name using degree would be 0 degree polynomial. Number of terms is 1, so we'd call that a monomial. So this is the 2 ways of naming our polynomial, either 0 degree polynomial or a monomial. The next case is 5x plus 9. We have 2 monomials. The larger exponent is 1. So this is 1 is the degree, so we call this a first degree polynomial. Number of terms is 2. The prefix for that with polynomials is binomial or bi, so this is a binomial. The next example, the highest power is 2, so this is second degree. And the number of terms is 3, so it's a trinomial. In the fourth example, the degree is 3, so it's a third degree. Polynomial. Number of terms is 1, so it's a monomial. Finally, in the last example, the degree, the largest power of variables raised to is 4. So that's a fourth degree polynomial. We have 3 terms, so it's a trinomial. Generally, after trinomial, we just call them polynomial. Another way to say that, however, is you also can just use the number of terms and the degree and say it's a fourth degree trinomial. Example 4, classifying, that is naming polynomials. Write each polynomial in standard form. What is the name of the polynomial based on its degree and number of terms? So standard form means write the monomial with the highest degree, then the next highest, and then the next highest, and so on. So we start with the highest, so I'll rewrite number 1 as 7x squared minus 5x plus 9. So the highest degree is 2, so it's a second degree trinomial because it has 3 terms. In the second example, my highest power is 3, so I'll lead with that. So I have 8x to the third. However, we note that we also have 3x plus 12x, so I'm going to add those two together because they have the same power of the same variable. 12 plus 3 is 15. So my next term will be 15x, and then I have the minus 13. So the degree is 3, so third degree. Number of terms is 3, so this is a trinomial. Example 5, subtracting polynomials. We want to subtract the 2 polynomials. They're both trinomials, although not the same degree. 2 different ways. One is vertical method and the other is the horizontal method. So in the vertical method, we line up the 2 polynomials one on top of the other. However, we have to make sure they line up with the same variables right over each other. So if in the case of the first trinomial I'm missing the squared term, that means there's really 0x squared. So I'll write a 0x squared just as a placekeeper. The next thing I want to do is distribute that negative sign to each of the 3 terms, in this case, inside the parentheses. So distributing, I end up with, in the bottom row, negative 4x squared minus x plus 12, because I changed the sign distributing the negative. Now I'm just going to add. There's nothing to add to the cubed term, so I have minus 4x cubed. 0x squared minus 4x squared is minus 4x squared. Negative x and negative x is negative 2x. And then 9 plus 12 is 21. And so that's what I get using the vertical method. The horizontal method, I line the 2 polynomials up as they are. So just as it was originally written, with parentheses, and what I'm going to do is I'm going to remove the parentheses. That's my first step, which means once again I have to distribute the negative to all three terms in the parentheses. So in the first case, I can just remove the parentheses, negative 4x cubed minus x plus 9. Distributing the negative, I have negative 4x squared minus x. Negative times negative is a positive. And now what I'm going to do is I'm going to put the terms that have the same powers together, which I don't have another cubed, so I won't put that together with another cubed, and I don't have another square, but I do have a negative x and a negative x, and I have a 9, which is a constant, and a 12, which is a constant. So I'll combine those horizontally. So I have negative 4x cubed minus 4x squared. Negative x and negative x is going to be negative 2x, and 9 plus 12 is 21. So we see that no matter what way we go, we get the exact same answer if we do it correctly.